Hello everyone. The purpose of this presentation is to emphasize the strategy to apply in the event of an engine failure during cruise. In the case of an engine failure in cruise, the remaining thrust may not be sufficient to maintain the cruising altitude with the remaining engine or engines at maximum continued thrust (MCT) rating. If you maintain the cruise level, the aircraft's speed will decrease. To avoid the speed to decrease below green dot, you have to descend to a more appropriate flight level where the available thrust can equal the required thrust to level off. The descent cannot always be operated in the same conditions. The descent strategy is generally determined by your flight operations department during the route study. They have to consider different strategies depending on constraints like ETOPS requirements or route over mountainous areas. When I mention ETOPS, I am referring to the EDTO operation as defined by ICAO standard. During this presentation, I will use the term ETOPS. During the flight preparation, you can review the descent strategy to adopt in the event of an engine failure. In the case of an engine failure during cruise, you may have to descend to the one-engine inoperative ceiling using one of the three following strategies: the standard strategy, the obstacle strategy, or the fixed speed strategy. The one-engine inoperative ceiling depends on the strategy. The REC max for one engine out on the PROC or perf page, depending on the aircraft type, that is the long-range cruise LRC ceiling with one engine inoperative. It corresponds to the standard strategy at long-range cruise speed. The drift-down ceiling on the perf page, it corresponds to the obstacle strategy at green dot speed. Or the flight level for the selected ETOPS diversion speed, it corresponds to the fixed speed strategy. Now let us take a look at the details of these strategies and, more important than that, when to apply them. If you are not flying ETOPS or over a mountainous area, you apply the standard strategy. To apply the strategy, you need to select a speed or Mach target that ensures the aircraft to be within the stabilized windmill engine relight in-flight envelope. This speed or Mach target is different depending on the aircraft type you are flying. In some specific airspaces, as for example the North Atlantic tracks, it can be appropriate to use first the obstacle strategy in order to minimize the loss of altitude while leaving the track. When the descent path is cleared, you can go back to the standard or fixed speed strategy. The combination of strategies may be defined through the airline's policy. If you encounter an engine failure over a mountainous area, you should apply the obstacle strategy. This strategy consists in descending at the green dot speed until you clear the obstacle or until you reach the drift-down ceiling. The green dot speed corresponds to the best lift-to-drag ratio speed where aerodynamic efficiency is maximum. Therefore, the obstacle strategy enables to minimize the altitude loss versus the distance covered. Once the descent path is clear of obstacles, you can apply the standard descent strategy. Now, if you encounter an engine failure during an ETOPS flight, you should select the ETOPS diversion speed. Your airline's operating manual provides this data based on your ETOPS approval. This ETOPS diversion strategy is referred to as fixed speed strategy in the Airbus documentation. The selection of the one-engine inoperative diversion speed affects the diversion distance, the fuel consumption, the obstacle clearance. For example, if you decide to increase the one-engine inoperative diversion speed, it will generate an increase in the available diversion distance for a specific diversion time, an increase in the fuel consumption, a decrease of the level of altitude. For more information on how this affects your ETOPS operations, you can refer to the Extended Range Operation chapter available in your Flight Crew Operating Manual. You can also refer to the Getting to Grips with ETOPS available on Airbus World. The combination of the strategies may be defined through the airline's policy. Now let us take a look at the different steps to apply in the event of an engine failure in cruise. In this situation, you must apply the following actions. Set all thrust levers to MCT. Disconnect the autothrust to avoid any engine or engines thrust reduction at the engagement of the descent mode. Set and pull heading as appropriate to ensure a safe trajectory. Determine the engine out sealing that corresponds to the strategy that is considered. When appropriate, notify ATC. On the flight control unit, set and pull the appropriate speed. Set and pull the engine out sealing corresponding to the descent strategy. It is important to recall here that the speed must remain above the green dot. If following an engine failure the speed rapidly decays to green dot, the crew must give priority to the initiation of the descent. When the aircraft approaches the engine out sealing, the rate of descent reduces significantly. In order to keep a sufficient rate of descent until the capture of the engine out sealing, a vertical speed of 500 feet per minute must be selected and the autothrust must be re-engaged. This technique has to be considered only in the absence of obstacles constraint. To conclude, when an engine failure occurs above the long-range cruise LRC ceiling, you must fly your aircraft making sure that the maximum continuous thrust is available on the remaining engine or engines. Adjust your lateral trajectory to follow the most appropriate flight path. Determine the ceiling associated with the intended strategy. When appropriate, notify the ATC. Initiate the descent at green dot speed the latest. The strategies that we described in these presentations are published in the Flight Crew Techniques Manual. For additional information about these strategies, you can refer to the Getting to Grips with ETOPS and to the Getting to Grips with Aircraft Performance. Keep in mind that Airbus has defined 3 different strategies that you can adapt depending on the constraints you encounter. I hope you enjoyed this briefing and see you around for the next one.